One problem that we're going to see pop up a lot, it's kind of tricky. And it's when we have, rather than just one term added to another term, we have a complicated term, maybe like a binomial or a multiplication where I have this term times that term and so forth. So in doing this, I want to be very clear where each term is at. And terms in a polynomial are separated by these addition signs or subtraction signs. So right here is one complete term. Here is the second term of this particular problem. Once I'm able to identify that and am comfortable with that, now I can look for what's the greatest common factor between those two terms. I look at this and what's common here? I have an x plus a 3 here and an x plus a 3 there. So my x plus 3 is my greatest common factor. And if I rewrote that then, that would be x plus a 3. I factor that out times an x squared plus x plus 3 times a 5. Use my distributive property, pop both of those out, make sure I have parentheses for what's remaining. What's remaining is an x squared plus a 5. I factored those terms. And look at the factors. The factors don't look like what we were used to. I basically have two binomials multiplied to each other, but it was factored correctly and fully. All right, my second example. Identify where the two terms are at. One term there, the other term is right there. What's common in both of those terms? I have an x here, no x there, so the x is not a common factor. I have a constant of a 2. There's no other multiple of 2 in the other term. I have a y plus a 1 here and a y plus 1 here. And remember, it has to be the entire quantity. I can't just say it's a y or a y, but it has to be this entire quantity, y plus 1. So y plus 1 is my greatest common factor. Re-express it as y plus 1 times the x minus y plus 1 times the 2. Factor out the y plus 1 using distributive property. So y plus 1. And then what's left is an x minus a 2. And there I have completely factored that particular initial setup.